Hello, everybody. Here, let's talk about the graph of f of x equals x cubed minus 3x squared minus 10x, and let's determine the maximum number of turning points. So the maximum number of turning points is equal to the degree minus 1. And here, the degree of this function is the highest exponent uh, of all of the terms here. So we have exponents 3, 2, and 1 on 10x. So the highest exponent that we see on the x is 3. So therefore, the degree is 3. So to get the maximum number of turning points, we just have to do degree minus 1, which is 3 minus 1, which is 2. Now, let's look at the graph to see if it really is the maximum number of turning points. So here's the graph of the function right here. And as we go from left to right, uh, it reaches a maximum right here, and it goes down. So that's one turning point. And then it goes down, reaches a minimum here, and then it goes back up again. So that's another turning point. So here's one turning point, and here is another turning point. And so the maximum that we can have is 2, so these must be the only turning points on this graph. So it seems to, so this graph seems to agree with the fact that we have a maximum number of 2 turning points. Now let's do B part, determine the end behavior of the graph. So what this means is we don't really, so we look at the graph again. So we don't really care about the middle here. So the middle tends to wiggle around a lot. But to determine the end behavior, we want to know what is it overall doing as we go to the left indefinitely and also to the right indefinitely. So ignoring the middle part, we want to know what happens as we go to the left and what happens as we go to the right. So therefore, as it stabilizes, what is it really doing? All right. So it looks like as we go to the left, looks like the graph keeps going down. Okay. So that would mean the graph is, so what this means is as x approaches negative infinity, the y seems to approach negative infinity. Okay. So that is as x goes down, the y goes down also. And then as x increases or approaches infinity, it looks like the y is also approaching infinity. That is, as x increases, y seems to also increase. All right. So that seems to be the overall picture of what's happening as we go to the left and also to the right indefinitely. To verify this or confirm this, we're going to find the power function. The power function is the leading term. So the leading term is the term with the highest exponent, which is x cubed. And so the power function is that leading term, which is x cubed. And so let's look at what the power function of p of x equals x cubed is doing. Okay, let's turn this off for now. And let's graph the function. All right, I know I should use f for this one since we used f on the paper there. So let's use p for the power function. All right, and so here's the power function in black, p of x equals x to the 3. And looks like as x goes down, y is going down also. And as x goes up, y goes up also. All right. And so that's what it seems to really be doing on the power function. And whatever is happening on the power function applies to the given function f of x in this case. Okay, so we'll note that, so we'll make a note of this for the power function also f of x as x approaches negative infinity. y approaches negative infinity, and also as x approaches infinity, y also approaches infinity. Okay, this applies for both p of x and f of x. All right, so that's the end behavior right here. Okay, so as x approaches negative infinity, y approaches negative infinity, and also as x approaches infinity, y approaches infinity. And that's the case for both of those functions in the long run. All right, and that's how to find the maximum number of turning points and also the end behavior of the graph of a function.